right, welcome everyone. Come on in. Great, lots of familiar faces. I love that people are putting their cameras on too. This is exactly what we heard and what people wanted. So this is wonderful. Welcome. As you join in, feel free to unmute yourself for a moment and let us know what city or what neighborhood, if you're here in Edmonton, you're tuning in from. I'm Warren. I'm tuning in here from Queen Mary Park.
I'm Anna. I'm here from Edmonton.
I'm Emily. I'm tuning in from Sherbrooke.
Nice.
Hello, I'm Payam. I'm tuning in from Vancouver, BC.
Welcome, welcome.
I'm Devanisha. I'm tuning in from Johannesburg, South Africa.
Wow. All right. Thank you for staying up late with us. This is great.
Martha, I'm from Calgary.
I am I'm Anand, tuning in from Fort McMurray.
Great, awesome. We've got lots of Alberta representation. We've got some international folks present. This is fantastic. We're going to give just a couple more moments before we dive into tonight's AI Meetup content, which we're really excited about. So bear with us for just another minute and we'll let some other folks join. All right, well, I'm going to kick us right into things. So welcome back, and for those coming for the first time, welcome. If you don't know, Amii is the Alberta Machine Intelligence Institute. We have a whole history, including decades of world-leading AI research and training that has put us in a position as a global leader in the field. And whether you're a business or a student or just looking to get more involved in the AI community, we have a whole host of different programs, events like this, and resources to support you. And we would love to connect. So throughout tonight, we look forward to some great conversations. And feel free to reach out to us. You can find us at amii.ca, that's amii.ca, or drop us a line at hello@amii.ca to learn more. If you have yet to come out to one of these virtual AI meetups, they're a lot of fun. We're going to keep this pretty quick moving tonight, so we'll blast through some stuff and let you get on with your Thursday evening. So we want to make sure you have a chance to connect with each other. So there will be time for Q&A and a bit more of that interaction with some of our presenters. So please take advantage of that and ask some great questions, and we look forward to some lively discussion. We will continue to make these meetups better and better each time. I have a standing desk today, which is my minor improvement since last time, but we want to make sure we set a low bar so that we can continue to exceed that bar every time we have one of these events. I will note that the session tonight will be recorded, and we will be having 2 presentations. So we always try to have a little bit of science-focused talk, as well as more of a applied use case, business case at each of these events. And so really great content for you tonight, coming from Ntwist and from Copysmith. If you do feel so inclined, please leverage the chat, and you can ask some questions throughout. We will leave it to the discretion of the presenter if they want to address that question, or kind of save it till the end and then jump on it during the Q&A session. But do feel free to light up the chat throughout. In lieu of the typical hanging out and schmoozing and carrying on that happens after these meetups, when we can have them in real life, we'd invite you to join us afterwards. There's actually a really great community event happening, TNT Investment Summit. And so we're going to pop over there to join for their happy hour and networking to follow this event. So we'll share that link in the chat, and you can jump right into that tonight as well. But without further ado, please provide a silent welcome, maybe a gracious nod or a wink or a thumbs up, or some clapping for our first presenter joining us from Ntwist. So take it away.
Can you guys hear me? Well, thank you, Warren, for the introduction. And hello, everyone. Welcome to Amii's virtual AI Meetup. My name is Nirav. I'm a research engineer at Ntwist, and I'll be talking about the application of machine learning in greenhouse gas emission in process industries. So let's begin. So before we jump right into the talk, I'd just like to say a few words about my organization and what is our vision. So what we want to do is we want to bring the insights from machine learning to help the people who are operating these huge facilities make some meaningful and educated decisions. And the question should be, the question would be like, what's wrong with the way they are right now, right? So the thing is, the nature of this industrial process is so complex that sometimes you cannot foresee the outcome of the decision that you make while operating it. And an ML can help you get some real-time perspective about the end result as you go. And we'll briefly see how in this talk. So with that, let's jump to the content. So this is the thing that we are going to see in this talk today. First, we'll see what is the problem statement and how and what is the relation between this GHG emission to the process industries. Then we'll see where we stand right now, what is the present condition, and then we'll see how from this condition we can move towards the solution, what should be the path for it, and the challenges that is in the way to solve these problems. And in the end, we'll see a real life problem that we encountered recently and how we solved it and what was the outcome of it. So with that, let's start the problem statement. So can you guys see my screen? Okay, so I'll just start again then with the slide. So let's talk about the size of the problem that we have right now that concerns the process industry. And the problem, again, like as I said, like most of the people know that this is the most pressing issue that we are facing right now. So climate crisis. So there are many things that we are doing to our nature right now that is destroying our nature, but there are certain small ones and there are a few big ones, and GHG or greenhouse gas are one of the big ones. So when I say these greenhouse gases, most of the people know that the carbon dioxide, but there are many of them. And let's see how process industry generates this greenhouse. So right now, most of the thing that you use in your day-to-day life could be from pen to the gas that you put in your vehicle. All of these things, they are made in these facilities. There could be some small scale plant to a large refinery. And we'll refer them as the process industry in this talk because they convert natural resources to something that we can use. And what these process industry needs, along with the thing that they use, is a huge amount of energy. And most of them uses fossil fuels or as we know them as coke, liquid fuel, LPG, natural gas, coal, to generate this energy. Now the chemical structure of this fossil fuel is such that when you burn them, along with the energy, it also releases carbon dioxide as a byproduct. And this carbon dioxide is one of the greenhouse gases. Just to have some rough idea, in the figure, if you see in the left, I would just showed here the amount of carbon dioxide each of these fuel sources emits into the environment. And if you just consider 1 year, 2000, in just 2017, just in Canada, process industries dumped 155.4 million tons of carbon dioxide. And everyone knows it's a lot. And this is just Canada. I'm not talking about the entire world. Uh, so then the question is why we are doing it. Well, the thing is that we cannot live without the things that we are using right now. So we cannot shut down this process industries. It's not it's something that we cannot avoid. However, we can most certainly operate them in more responsible way or more optimal way, and we can reduce these emissions. So this is the motivation behind the talk of uh, today's talk. And next we'll see, excuse me, next we'll see where we stand uh, in terms of handling this, or what can be done about it, what should be the path to the solution, right? So uh, right now, uh, the process industries, they employ thousands of sensors to keep track of the operation, because they are huge facilities. And what's happening at each and every point of it is very important to know. So they employ this sensors, and what the sensor essentially do is they capture the image of the entire plant. And this images is captured ranging from few seconds to a minute. So essentially what you can say is that these plants, they have years worth of plant images stored in their databases, which makes them data rich organization, which is something different than what we see in the other machine learning application, where you first have to collect the data, then you have to annotate them, and then you can use it for some meaningful application, which is not the case, and it's actually a good thing. However, if you see the way they are being used right now is mostly for day-to-day monitoring, just to make sure that everything is running fine, or probably they're directly being fed to control, so the control can automatically take care of the plant, or can maintain it, or probably for alarms, so just to make sure that everything is staying well they were supposed to. So one study says that out of all the data that are collected in process industries, only 10% of this data is used for further aims. And when I say further aims, it's just for simple applications, such as how many times they had shut down, or how many times they went off the specification of the product, or how many times they violated the safety rules, things like that. Now, one good thing about this situation is that the people who own this data, or the people from industry, they know very well that these data are capable of way more than what they are being used right now. So, and they're more than willing to work on it to get some real life insights. So so now we have a problem. We also have a means to solve it. Let's just see how we can approach this to find a solution. So in this, as I've just described, we have a plant which is essentially generating three things. One is the thing that we want out of it. Second is greenhouse gases, and third is the data, lots and lots of data. So all that is needed to be done is we need to just take this data, feed it to our data hungry machine learning algorithms, which could extract some meaningful insights out of it, and then feed it to the control room. So the people who are operating the plant can operate based on it, and we reduce greenhouse emissions, and along with it get some benefits. So seems very simple enough, pretty straightforward, right? Then why we are not using it? What is stopping us? So that brings us to the challenges that we face in applying the solution, or get some insight from machine learning. So in order to make it more clear and make it more intuitive, the challenges, what we are going to do today is we are going to operate our small plant of our own, and then we'll see the kind of problem that we face when we operate the plant. So let me introduce you to the plant. So this is our plant. It's a small tank heater, and the goal of this tank heater is to heat the water. There is some water coming in and some water going out. Use a marker, and our job as a plant operator is to maintain the temperature of this water at 50 degrees centigrade. right? And what we have to do that is this knob in the left. What it does is it regulates the flow of the fuel to the fire, which generates the heat. So say we are given the control of this plant right now, and after some hunches, we managed to find a point where it maintains the temperature to 50 degrees centigrade. Job done. We operated the plant, right? But wait, suddenly the water that was coming in, the temperature drops. So now you're not 50, it's going down, and then you again struggle for some times, and then ultimately you find a point where it is again where it was. But hey, you live in Canada, weather changes. So now from summer it's winter. So again you struggle, and you again find a point where again you are back to where you want. So this is just the simple things that I describe, and this temperature it could be different than what it was before. So again you have to find a point where you can again maintain it where you want it to. So as you can see, there are so many complexities. So there's so many other things that can happen when you are dealing with a plant. Some things you cannot even force. If, for example, if someone starts taking more water out of it, your level drops, and then again your temperature rises. So there's so many complexities and so many interdependency between things that makes this very complex thing to handle or to control, right? But this is not the only thing that you have to take care of. This is not the only thing. The temperature is not the only thing that you have to take care of. You have to also look out for these things, safety. So every time you make a change, you have to make sure that you're not putting too much fuel into the fire. Otherwise, it may cause a fire. Or you have to make sure that you're not over pressurizing this tank. Otherwise, it was just blow apart. Now, this is just a simple example of one tank. Imagine 6 of this tank connected to each other. And now your job is to maintain the temperature in each and every one of them. And changing the heat input to first tank may change the temperature of the last tank. And now try to do the same job with this many uncertainties. So this is the kind of complexity that we talk about when we deal with process industry or a chemical plant. And here we are just operating the water. Imagine we are handling a chemical which can be flammable. So so this gives us an idea about how much complex the nature of this processes are, and the other things. So let's just do a head count of the challenges. So first of all, it's very complex. No matter how much experience you are, there always can be some things or few things that you miss out and you cannot foresee them, and most often those things may lead to something very bad. So they're very complex. Second thing, they need subject matter expertise. When I say that, in order to do anything with these plants or process industry, you need to know everything about it, so that you can know that the things that you can play with and the thing that you should not touch. So it needs subject matter expertise. The third thing is safety, that before doing anything to it, you have to make sure that it is safe enough to do so, because if you don't take care of it, it has the fourth thing, destructive potential. And you may end up blowing everything apart, and you don't have a plan to operate. And it happens. It has happened many times in the past, and most often it involves loss of lives. So this is the reason why it is very hard when we want to apply our solutions to the process industry. So again, since the process is this complex, there is no way that expertise from just one field or one domain can solve the problem, right? We need expertise from many fields. So we need expertise from engineering, so so that it can give us the insights about the process. We need expertise from control, so it can give us insights about how we can bring upon the changes that we want to. We need inputs from computing science, so that we can take the inputs from these two fields and convert it into the machine learning solution. And in the end, we need insights from statistics, just to make sure that the data that we're using has a potential to solve the problem that we want to solve here. So once you combine all these things, all these efforts and the data that you already have, then you can get to uh, I guess a solution, and along with that a reduction that you're aiming for. What I just want everyone to take away from this slide is that it's pretty obvious that we are using a knowledge of science that we already have, and we are applying it to a data that already exists out there, and we are creating something here that definitely helps people who are using it in the plant, right? But it's more than that. It is also helping us as a society to reduce the consequences of our action that we inflict on nature, like the things that we inflict on nature. It's directly helping us to do that. So it's just more than the solution for these industries, is what I want to say about this. And with all that being said, I just want to showcase like how much difference you can make in the real life with this problem that we encountered in the past. So this is a flow diagram of this plant that I'm going to talk about. It is called HPAL, or high pressure acid leaching. It is used for nickel extraction. Nickel is again used in batteries, and it's pretty famous because of the electric car these days. So the process goes like this: that you dig up the nickel ore in the raw form, which has nickel, but again it has so many things with it that you have to separate them. And once you have this ore, you crush it, and then you screen it to get rid of all the muds and all the wrong particles and silica and everything. And what you end up with is called ore slurry, which you can see here in the left. And out of this ore slurry, if you want to extract the nickel, what you have to do is you have to feed this ore slurry to this tank, which is operated again at very high pressure and high temperature. uh, Highlights the safety. And you mix it with the steam and sulfuric acid, and then you mix it. You use the tank has a couple of agitators, and the chemical reaction takes place between sulfuric acid, steam, and the nickel, and it ultimately takes out the nickel from the ore. And reaction progresses as it goes along this tank, and in the end you get the extracted nickel. And this nickel is then separated here, the purified nickel, and impurities are again goes back into the other tanks. So this way you get the purified nickel. So this is the process. So you must wonder, like, where does the greenhouse comes in this? So first of all, HP steam, or high pressure steam. To generate steam, you use boiler, and in boiler you use natural gas. And as we saw in the first slide, natural gas is one of the biggest contributor in carbon dioxide, right? And the second thing is sulfuric acid. So what happens is, when sulfuric acid reacts to nickel in this chamber, there's one byproduct, which is called sulfur dioxide. So sulfur dioxide is also a greenhouse gas. So our goal is, with this problem, so this is the plan that I explained. Now our goal is to identify a point, or the combination of this steam and H2SO4, the least amount that can still maintain the purity of the nickel that we are getting in the end, or probably improve it. So basically we have to find out the best combination of these two. So this is the problem, and now we'll see how we solved it, and what was the outcome of it. So what we essentially did was, here is the plant. We had years worth of data. So what we did was we took that data and created this module which is called digital twin. It uses machine learning again, and again experts, as I mentioned earlier, because it's very important. So with these two, we created this digital twin. What it essentially does is it is a twin of your actual plant in mathematical form, obviously. So now you have exact replica of your plant with you, and now you can try different things and see what would be the outcome, what is the purity that you're getting, whether you're violating any safety constraints or not, and things like that. And then we feed this digital twin to our decision making algorithms. So what this would do is it would try a bunch of combination based on the algorithm, several of them basically, and then it would find out a point which minimizes the steam steam and sulfuric acid and still maintains the purity of nickel that you are getting, or probably even improve it with the least amount of steam and sulfuric acid. And once you get this recommendation, then they are being fed to the control room. And based on this recommendation, the people in the control room can take an informed decision whether they should go with it or not. And this is how the entire thing works. Next, we'll see how it looks like after developing this solution. We deployed it in the real settings. We deployed it in the real plant. So, oh, sorry, I think it is not visible. Uh, how it looks in the real plant. I guess there's something wrong with the slide, I guess. I guess we have to skip it. But the thing is, after implementing this solution, the outcome that we got is this, that we achieved a 42% reduction in the consumption of greenhouse gas causing reagents. So it's almost half. We reduced it by half. But this was not the only benefit. Since now we are using less amount of steam and sulfuric acid, the plant saved $1.7 million in their capital costs. So in the end, I'd just like to say that with the insights from ML, definitely you can make a smart decision and operate smartly and help save money. But it also does way more than that. And then this 42% that you see here, it speaks for it loud and clear. So thank you for joining us, and hope you guys enjoyed the presentation. And if you guys are interested in solving a problem like this, you can get in touch with us. Again, this presentation was a joint effort from myself and my colleague Grayson, who is also here. So yeah, I'd be happy to answer questions. I'm sorry there was some trouble with the presentation, I guess. It's not the way I wanted it to be, but yeah, thanks.
Yeah, thanks. Thank you so much, Nirav. And yeah, really, thank you to everyone who has stuck it out with us tonight. Really appreciate you bearing with us through these challenges post from our new virtual world. So thank you, really, truly, thank you so much for sticking with us. If anyone has questions for Nirav, now is the time.
Hi.
I am. Go for it. Oh, Emily, go ahead.
You can go ahead, Emily. I can go next. That's fine.
Okay.
Please go ahead.
May I ask what algorithm you used in this particular instance?
So for this,
Mhm.
the decision-making algorithm you're talking about?
Mhm.
So we, in this case, we use reinforcement learning.
Okay.
Yeah. But there are other things you can also use optimization. Depends on the kind of problem that you're solving, right?
Right. Like I would have thought something along the lines of simulated annealing would have been good for this as well, in my unprofessional opinion.
Yeah.
I yield my time.
Okay.
Okay. So I'm curious about that. Can you say a little bit more about the digital twin? How do you go about making it? Is that just a simulator, or from what I understand, it is a simulator, but you also stream data into it. Is that correct? Or
so it's
say a
not a
little bit more?
simulator. It's something that we have created with. So you get the data from the plant, right? But then you have to find a right structure that can represents the reality of the plant, right? There are so many things. Even in the modelings, you can even go. Sometimes you can get away with simple models like linear, and sometimes you need to go for more advanced things, as LSTMs or things like that, right? So we basically take the data and then we find the right structure for it. And again, we use the operational experience from the people who are already operating the plant to make sure that that the thing that we have in terms of this digital twin, whether it makes sense or not. And they obviously they recommend changes based on their knowledge, and that's how we come up with this final thing, which very closely represents the actual plant.
I have a question.
Mm-hmm.
Nirav, I'm a process engineer, so I can probably understand this better. I wanted to ask you, you mentioned that your aim was to reduce steam consumption, which translates into reduction of the energy.
Mhm.
And obviously, if you're burning less fuel, then it's less greenhouse gases.
Mhm.
Okay. So what I'm trying to say is, normally the amount of heat that you're going to put in, it is
Mhm.
temperature controlled on a control valve.
Okay.
That is normally done. So if the output temperature from that bath heater is to be maintained constant, then those controllers are going to take some sort of an action to reduce or increase the steam flow as well as the amount of energy, which is natural gas in this case, to heat the water.
Mhm.
So so what is machine learning doing here? So there is a control mechanism already in the plant. The operator
Okay.
is not, I bet the operator is not probably touching those control mechanisms because that's automatic.
Yeah.
All that he will probably do is change on the setting point.
Yeah. Yeah.
Okay.
So the thing is, so since you're a process engineer, probably you would understand there are two kind of process controls in the plant, right? One is supervisory control, and the second is the regulatory control, right?
Yeah.
So here we make the recommendation for supervisory control.
Okay. So you
Yeah.
are going to give the controller a certain
Yeah.
input.
Yes. Yes.
Okay.
Yeah. We make the recommendation for the supervisory control system.
You haven't shown us any graph that can do you can you show something that can
So
reveal something more?
so the thing is, like, I actually have put the graph, but for some reason there is some problem with this presentation. And I cannot. I don't know why. I mean, like, I couldn't see it in the. There is actually a graph where I have just demonstrated a solution over here, but I don't know, for some reason it's just not displaying. It is in my preview though, but it's not when I present it in slideshow. It's not just coming up.
Okay, that's fine.
Yeah.
Thank
Yeah. Yeah. But if you're interested,
Awesome.
yeah, I'd be happy to explain it in the detail. Yeah.
you. Yeah, sure.
Yeah.
Can I ask one more question?
Yeah, that sounds great. One more, and go ahead.
Yeah, I was very interested in actually the control loop that you showed us. I was wondering if you have tried, using learning-based model predictive control instead of reinforcement learning for your control loop.
No, not yet. No, sorry, we haven't tried that.
Okay, because model predictive controller actually is much simpler than RL because you have to train
Yep.
RL, right?
Mhm.
And how long did it take to train the reinforcement learning agent?
Then again, it happened in the steps, right? There were many iterations involved in it until we reached our final solution. But again, model predictive control definitely is a solution to it. But the thing is, I mean, you have to maintain those models, right? Which could be, that is one of the hurdles that that the people who are operating this thing, they don't want to go through the trouble of. I mean, they don't want to get into the trouble of maintaining the models every instant. And yeah, there's some problems, I guess, with MPC. I mean, we have explored all the options, and then we settled on this because it was like the least resistance in this.
Okay.
Yeah.
Thank you.
Yeah.
Fantastic. Well, thank you so much, Nirav and Ntwist, for a great presentation tonight, and again for bearing with us. That's definitely been one of the most challenging virtual presentations that I have ever seen. So kudos to you for seeing it through and helping get that great content to us. Really appreciate it. I do want to take a quick moment as well before we jump into our next talk. If anyone in the audience here as an attendee wants to put a quick call out if you're looking for something, or if anyone here is hiring, to be able to say, hey, yeah, we're hiring, and hit me up here if you're interested. Feel free to take a moment now.
And if you guys are interested in, I mean, if you guys want detailed answers of any of the questions that I might not answer right now, yeah, feel free to reach out to me, and I'd be happy to help you, or like give an explanation, I guess.
That's great. And we can help you get in touch with Ntwist and Nirav as well. So feel free to reach out to us and we can connect the dots there. But go ahead, Payam.
Okay, yeah, so I am a research scientist at MDA. We actually have, as far as I know, our Brampton office has a partnership with Amii for applications of AI and reinforcement learning to space. I just wanted to mention we are a gold sponsor in NeurIPS. So if anybody here is interested in working with us in the future for space applications, we do a lot of reinforcement learning, deep learning. Please come to our virtual booth. I'm assuming a lot of people here will probably be attending NeurIPS. It's going to be virtual this year. So, and I will be presenting in the next one of these. So if I'm happy to answer any more questions then. But that would be after NeurIPS, so that's why I'm asking you to come to our booth if you like. And there will be HR, and if you're interested in working, you'll be able to get in touch with us, or you can contact me directly, and I can put you in touch with the right people. Thank you.
Fantastic, thank you. I will also take a moment to mention we have a posting available at Amii, so you can find our machine learning project management role on indeed.ca, and if you're interested in applying, you can reach out to us to learn more at hello@amii.ca as well. But that's great. So lots of exciting stuff, and you'll be able to hear more from Payam and MDA coming up at next month's meetup. So lots of great conversations to come. All right, we're actually going to dive right into talk number 2. So please join me in welcoming Jasmine from copysmith.ai. Take it away.
Hi everyone, Jasmine. Let me just quickly share my desktop. So I'm actually going to start today with the product demo, and then I will explain how it works. So copysmith generates with natural language generation, basically all the copy that a marketing team or founder needs. So I'm just going to go into the platform, and this is a free trial, so anyone can go and do this. And I've actually run out of things on my plan, so I'll just show you things I've generated, and then I'll generate 1 or 2 things live. And then if we have extra time at the end, we can generate away. So these are all the content types that we're currently generating, mostly short form. And how the platform works is you just enter in a few key parameters. So in this case, this is like a chocolate brand. I grabbed these things from like just what was listed on the site about Mast Brothers, and it generated within like 10 seconds about 12 to 15 unique product descriptions on the right. So I'm going to scroll slowly through just so you have, this was my edit for a client. So take that out. I made that error, not the AI. I'll show maybe one more example, but basically what you can see here is like it looks quite like human-like, which was like very impressive to me when I first looked at it. So again, like putting all the templates sort of operate in a very similar way. You put in like key characteristics that like any entrepreneur probably knows about their business, and it generates content for you that's adherent to templates. Cool. I'm going to stop sharing this, but we can like come back to this at the end of the presentation. Cool. So I'm going to do just a very quick skim through the language models, like motivating why language models have like developed in a certain way to my understanding. I will caveat that this is like potentially a historical like gloss over what has happened, and I'd be like very excited for members of the audience to correct me. So I'm the founder and CEO of Copysmith. My background is in computer science, and I've worked at a variety of places, OpenAI, on the GPT-2, and Microsoft Research, as well as Mila. So very broadly speaking, there are like 3 kinds of language models: rule-based, retrieval-based, and generative-based. And prior to last year, I actually was working mostly on retrieval-based models for the purposes of dialogue or chatbot. So actually generative models are like very new for me. Let me see. Cool. So just some like quick illustrations in case you like don't really know how this breaks down to. So role-based is like very typical like logic and computer science. Like it breaks down like if you can respond in a certain way and you're put into like one subset of a complementary set of things. So there's a very fixed like tree. Retrieval based means that there's like a corpus of potential responses and the model retrieves the best response. So you're not generating each response uniquely. Where the domains in which this sort of model is like probably useful is things where you want to make sure the answer is true. And this sounds really trivial, but it's not. For example, like the generative model that you just saw on copysmith, we don't like the AI has no notion of truth. It's generative. It generates things token by token. In things like I was working with medical wikis, for example, you want to be like pretty sure that the answer is true, in which case a retrieval-based model makes sense. I'm going to talk mostly about generative models today, but I wanted to just give that like quick background as to like how we can like think about and contextualize these models. So also going to skim over this pretty quickly since I'm guessing a lot of folks in the audience probably know about this, but just going to quickly motivate like why transformers are sort of like the most popular paradigm for building natural language models. So there are problems with things that came before, recurrent neural networks and long short-term memory. So the primary issues with RNNs were they took a really long time to train and they had problems with long sequences of data. And long short-term memory did better with long sequences, but they were even slower. Fast forward to GPT-2, which is, so OpenAI came out with a series of models. They had GPT and then they had GPT-2 and GPT-3. And I'll talk quickly about the differences, which there are very few between GPT-2 and GPT-3. But just want to mention the primary differences with, I'm trying to motivate them like intuitively. So why RNNs had issues and LSTMs were, when I am speaking the sentence to you, it occurs to you in time. Like you hear a word sort of one by one, and if you were to reply to me in conversation, you would also reply like one word by one word. And if you were to like conceptually model RNNs and LSTMs, they sort of do this as well. Like they process words one by one and they also generate them. What was really interesting about GPT-2 was not the first model to do this, but some of the innovations that they used kind of get rid of this temporal bias by way of using positional encodings and attention. So positional encoding captures where a word is within a sentence. So if you look at these two sentences, the word dog, it means very different things in these two contexts. And part of it, only part, is to do with the word order. But a positional encoding helps like capture where a sentence where a word occurs in comparison to other parts of the sentence. Attention is can be thought of as a mask. So for example, in the sentence on the right, the word it could refer to like many, many different things. The word it is very vague. And what this visual is trying to describe is that oh no, it's very hard to talk about the word it because I'm trying to, anyway, the word it is paying attention to the animal in this sentence. Which also helps with like temporal issues because it occurs like later in the sentence. But the attention mask helps us know that it is referencing the first part. So this is another visual that I'm probably not going to explain, but I can come back to it if useful. Also going to skip this. So what GPT-2 was like famous for partially was that not the entire model was released. So initially only small, actually I'm not sure if medium was released, but I think it was either small and medium were released in terms of the weights. So people only had access to the code. It was later estimated that the GPT-2 extra large cost around $80,000 to train when someone replicated it. But then basically the larger the model gets, the more powerful it was. And there were like serious performance increases with the large and extra large model that the team was worried about in terms of like societal implications. I'm probably going to skip over this part. Sorry, I did some surgery over an earlier presentation. So a lot of people try to achieve better results with fine tuning. And I want to briefly motivate fine tuning because we're actually also using it in copysmith for some of the applications that GPT-3 is not allowed for. So if folks aren't aware, like GPT-3 is only available via an API, and the OpenAI team has only approved certain use cases for generative language models. So we're working on fine-tuning methods to work on use cases that currently not approved by GPT-3 for various reasons that I'll also get into a bit later. But why fine-tuning? If you haven't fine-tuned a model before, you should just know that fine-tuning is much faster and also requires much less data, which is sort of the crucial part for any startup that's just starting and doesn't have a massive data set moat. I'm going to briefly talk about PPLM, and the plug and play language model from Uber. And the only reason I'm talking about it is to motivate GPT-3. So how I conceptualize PPLM is that you have, sorry, the slide is a bit wonky or shifted to the right. But how you can think about PPLM is you have a bag of words that's on top of GPT-2. And that GPT-2 model can be just a pre-trained model or it can be fine-tuned. But the bag of words keeps the generations on topic longer term. So the gold standard for natural language generation is long-term coherence. If you can even probably think about human intelligence in terms of long-term coherence, like how many coherent words can you say over the course of an hour? Natural language models, I'm not really sure as to the state of the art for this, but GPT-3, for example, it can generate basically coherent blog posts and things that look like very, very convincing. GPT-2 can't, but there are various hacks, and I would classify PPLM as a hack, not in a derogatory way, but it is really getting around this problem of how do we keep generations that are a bit longer coherent. PPLM has this bag of words in order to do that. So let's imagine GPT-2 is generating, but we really want to keep it talking about yummy kebabs. So the bag of words here has food, kebabs, yummy. So it's just more likely that, or sorry, these are probabilities of the next words. The bag of words I think is cut off somewhere, but all the bag of words are related to food. So out of these words that it shows on the screen right now, it's biased towards food related words. Cool. So yeah, this is to maintain consistency, and basically it's a hack to store more context when there aren't enough parameters in the model. But a model 10x as big as this would probably do it by itself. That's GPT-3. So GPT-3 is 3 orders of magnitude bigger than GPT-2. It's the exact same model. It's just much, much bigger and trained on a much larger data set. It costs about 4.6 million USD to train. And this is actually the most interesting fact for me about GPT-3. It's 3 orders of magnitude smaller than the number of synapses in the human brain. And for some people who try to think about performance in AI, some of them base it off of exactly that, how many synapses in the human brain. If you want to get really literal about the metaphor of neural networks, we're getting close to something like the human brain. And people were very, very surprised about the performance of GPT-3. So I'm not going to do a full explainer of GPT-3, but some clarifications of things that you might see in the paper. So autoregressive GPT-3 predicts next token. A token is approximately 4 characters. This varies with different sorts of characters, but usually 1 token per 4 characters. What they mean by 0 shot and few shot is sometimes different from what other papers use, how they use that term. 0 shot means that there's 1 example in the context. So for example, you can say generate a Google ad like this. You would have an example of 1 Google ad and then it would generate. That's what they mean by 0 shot. Few shot is a few examples in the context. Usually a few shot in normal papers means gradient updates. They mean it, what they mean is prompting. What things are you telling GPT-3 to do? And I'll dive a little bit into that in terms of what we are telling GPT-3 to do for copysmith. The last thing that I would flag about GPT-3, which is just interesting from a societal impact standpoint, the latter half of the paper does mention that they did tests with humans to see if they could differentiate between AI generated articles by GPT-3 and human written articles. And it was actually almost down to chance. It was very, very close to 50-50 that they were able to recognize articles as AI generated. And you might get some premonitions now or hints as to why they are not allowing certain use cases of GPT-3. Mostly fake news. Cool. I just want to include this graph just as an interpretation for the audience. We see below that with smaller models than GPT-3, that with more examples, it doesn't improve. So at 1.3, so the smallest GPT-3 model is 1.3 billion parameters. This is the largest model, 175. You can see that with more examples being shown to it, the 1.3 billion parameters model stays fairly flat, whereas the largest model seems to still be increasing. Like there are still performance gains to be had, which I thought was also interesting. Awesome. So I'm going to actually open up the floor now and go back to Copysmith, and I'll probably start talking through. I'm out of generations on this account, so I need to log in again. But I'll talk through a little bit about like what we were doing in terms of GPT-3 and what we're also doing in terms of PPLM after I log in again. But I'm also very happy to take suggestions from the audience as to what they would like to generate content for, because I'm happy to do some live just so we can see how it looks. Let me log in. So just to give, I can't expose the infrastructure or the backend here, but like for transparency for all of you, like what was really amazing about GPT-3 is it sort of understands in natural language what it wants you, what you want it to do. Like basically for GPT-3 is so simple. Like I just basically said, I want you to write product descriptions for us, and gave it some examples of like how to go from this input to this sort of output. We are imagining now a lot of different human in the loop interactions for AI. It's not just a one-click interaction, for example. Like this is just one branch of a taxonomy of interactions that I think are possible. So this branch, I think, could be understood as you put in raw material, you get stuff that's 80% there, and then you smith it. Like you take it back, you improve it. There's clearly bugs, like this bagel description starts talking about Tesla. So the human is still important. we still need them in the loop. But there's other interactions that might be interesting. For example, I might find this description really interesting, but I might want to see like different adjectives. Like can you just have a parameter here that's like, okay, can you generate like 12 variants of this with like different adjectives? Or can you make this like shorter or like more blunt, or like all these different sorts of parameters? And I would really position like you as a human in this context as like, what would you want to be able to tell a really talented but literal writer if you were acting as an editor? Like, okay, I want you to switch out all the adjectives here and also make it about 200 characters shorter. So that sort of specificity would be required. But overall, the iteration time is just so much faster if like humans and AI are able to collaborate together. I'm going to pause there because I can just keep rambling if no one talks, but I'm happy to take questions. And I'm also happy to just like go through a demo of any of these on the left live. The thing that we are working on that will be closed beta is blog posts. That's not an allowed use case of GPT-3. We're probably going to use PPLM. You can imagine from my explanation of PPLM how that might work. But that's what we're currently working on.
Awesome. Thanks, Jasmine. This is really, really cool. For your, I'm going to ask the first question, but also we'll be able to let other people jump in. For each of your like AI generated snippets of content, are you having each of those reviewed through a human in a loop for every one of your clients?
Right.
At the moment?
So what I mean by human in the loop is the customer human in the loop. So like they can click generate, them liking it is stored in our database and it's added to our data set of like, these are the things we should fine tune on. Well, we're adding more human loop things based off of like editing deltas, that sort of thing, with active learning. But what I mean by human loop in that context is like the interactions that are customer facing. Blog posts, however, will probably have a human loop. We're still not sure what quality bar we can meet yet. So it's a question of both quality bar and unit economics of like how we release blog posts. We probably could release blog posts in a coherent way where we ask people for the first sentence of every paragraph and just use like a less state-of-the-art model to generate that. There's just some questions for me, like personally, about, okay, we don't want to help people generate low quality content. Like one of the appeals of GPT-3 is that it is quite high quality. It's frankly like better quality than a lot of things you see on the internet. We just want to figure out how best to like roll it out. It's possible that we will have a human copywriter look over the AI generated text and it just makes them a lot faster at doing what they're doing. Or it might be completely customer facing and they're sort of left to their own devices. But in either case, we're rolling it out to a very small number of customers first and just figuring out, okay, like how does this look? What's the potential for abuse? Those sorts of questions. If there are no more questions,
Right.
I can just continue showing different demos, but I don't know how interesting that is to other people.
It looks like we've got a question from Emily here. So yeah, go ahead, jump right in.
So as I understand it, the model you're using is based off of GPT-2, which is a model that was already trained and then it's just been further refined?
No, so all of our templates are GPT-3 powered, with the exception of blog posts and potentially other types of content that fall outside of what's currently allowed due to like quality, literally like concerns that the quality is too good and not really differentiable like from the perspective of humans.
But it's an AI that was generated for general word generation and then
correct
amended to a specific task. And my question is, do you think this kind of thing will become more common as computing power increases? Or
I think all instrumental writing will be non-existent in 2 years in the way that we currently conceptualize it. I think all writing will be AI assisted. You see some of this with Smart Compose, Gmail, GDocs, but actually what we're aiming at is like fairly different from like a simple autocomplete. I think everything is going to be AI assisted, and I think there's going to be different paradigms for it happening. So like one thing I really care about is preserving human agency. So one thing that I don't like about Smart Compose and Google Docs is that Google Docs doesn't really tell you like why they chose that word for you and like what sort of likelihood it was. Like I just like want more information, and it doesn't give you multiple options. Whereas I think a really important feature of our platform, and I say this like genuinely, is like we generate a lot of options for you, and you as a human still have creative agency in how you put those together and what you take. Versus like with Google Smart Compose, it's like, oh yeah, like I don't remember what I was going to write, but Google said something that was like mediocre, and like I know it now. I think, yeah, to answer your like question directly, yeah, I think everything is going to be AI assisted at the very least, and potentially fully automated. And it's sort of up to us and up to the market what solutions are like ultimately the winners, so to speak. I would prefer ones that keep humans like in the loop.
Awesome. My next question is if there's any detail you can share around kind of what trends you're seeing with the types of companies that are leveraging the tool so far. Like, are you seeing like it's a lot of e-commerce, like products sellers, or that kind of thing? What's that look like?
Yeah, totally. So product descriptions are our most popular template by far. I'll probably log out and log back into mine. I think mostly because people are less worried about like things being SEO optimized, and we're still figuring that out. So most of our like the folks that have come on are like e-commerce or they have lots of SKUs. We actually just got Marshalls, which is really exciting, just like having with like a ton of products online. Agencies who just like deal with a ton of clients and have to write a ton of copy. But yeah, product descriptions are like by far our most used template. And I think that definitely points to like e-commerce and just a lot of stores also just moving online. I think trends will also definitely change because we only launched publicly 3.5 weeks ago. So everything is rapidly changing. But yeah, I definitely invite everyone here to like just go to copysmith.ai and try it out. Like you don't need a credit card. You can just like sign up and play with it. And would love your feedback. But yeah, just also feel free to try it out. It's actually a lot of fun. People write really weird things. Like some people like just try to describe themselves. Like you probably put like Jasmine Wang, like NLP researcher, and probably spit out something that's like interesting.
That's awesome. Is there any other aspect of the product that you want to dive into here, or if anyone else wants to jump in with any other of those now?
Oh, I think maybe the last thing I'll say is that I think machine learning as an API is like both like API infrastructure is becoming really popular as like a new area of development, like cortex.dev. I would point people to in terms of like really easily being able to deploy your own machine learning models as an API with just a YAML file, which is an option that we were looking at. And a lot of folks inspired by OpenAI are deploying their own models as APIs, which I think will just be like a trend like broadly in the future. And will probably enable like the next wave of machine learning companies. It'll just be really easy to start an ML company.
Awesome. Well, please, everyone, join me in thanking Jasmine for presentation tonight and spending her time with us, showing off the product. I think it's a really exciting product. I admittedly had signed up for a demo account even prior to tonight, so it was awesome to get the insider's perspective before I jump in and play around on there. So I'm looking forward to that. I will note again that I shared the Startup TNT link in the chat here. So if you're interested in carrying on the discussion and connecting with some other people around our tech community, it's an awesome event happening over there, and I would encourage you to jump right in. I'd like to give one final thank you to our presenters for tonight for sharing their time and expertise with us. All of you attendees as well for taking the time out of your evening to join. We hope to see you again next month, where we'll have some more great presentations. In the meantime, I'd encourage you to let us know your favorite agriculture company and encourage them to apply to our upcoming cohort of REMI around reducing emissions through machine intelligence. Lots of exciting opportunities for applications there and leveraging our strengths in Alberta around agriculture for reducing emissions. So we're looking forward to some exciting work there and some future presentations at this meetup from some of those companies in that space as well. So thank you so much for coming out, and we'll see you next time. Have a great night.
Thanks, everyone. Good night.
Thank you, everyone.